Let's begin our discussion on how to determine limits using something called the squeeze theorem by revisiting a function that we looked at in topic 1.2. In that topic, as we were talking about limits that may or may not exist and why, we stated that the limit as x approaches 0 of the sine of 1 over x does not exist. And the reason why was because as x is getting really close to 0, this argument inside of sine is getting really, really large. In fact, it's approaching infinity, which is a topic we'll discuss later in this class. But as x is getting really close to 0, the argument of sine got really, really large. And what it caused, as we zoomed in on that graph, it caused for the graph to oscillate between -1 and 1, and it just oscillated faster and faster and faster as we got closer to 0. And because of that, the limit did not exist due to the oscillating behavior. We had defined the limit as we had to approach some sort of specific finite value. And because we were bouncing between -1 and +1, we did not have a finite number we were approaching. We were just bouncing back and forth faster and faster. Well, let's make a little modification here to the function. And let's take a look at the limit. We're still going to approach 0 here. And I want to take this function sine of 1 over x, and let's throw an x squared in front of it. And take a look at the limit as x approaches 0 of x squared times sine of 1 over x. And we have a couple of competing forces here now. We still have the idea that the argument inside of sine is getting larger and larger, and we still have this oscillating faster and faster behavior. But we also have the x squared, which is getting close to 0, and that's affecting the amplitude of the function. We can say that the amplitude of this particular function is being shrunk down as x approaches 0. So what we have is we still have this oscillating behavior where it's oscillating faster and faster. But instead of oscillating between -1 and +1, that's now being shrunk down. And maybe you can already start to see why we're going to call this theorem the squeeze theorem, because we're actually going to be able to evaluate this limit after we say some very specific things about this function and we look at some of the limits of bounded functions. And that's what we'll cover here when we look at the squeeze theorem.